All right, let's talk about example 4. It says, suppose the total cost function for x units of a product is given by that function there. Graph the average cost function for this product and determine the minimum average cost. So, the average cost function is usually denoted by this little bar like that. And notice that it's just going to equal our cost function divided by the number of units that we sell, which should make sense because C of x represents the cost of making X number of units. And then if we divide that by the total number of units that we make, that should give us the average cost that we've spent per unit. So if we wanted to figure out what that was in this scenario, we would take our cost function and we would divide it by x. Now, notice that this is now a rational function because I am dividing a quadratic by the x, which is a linear expression. So what we want to do now is we want to think about graphing it. Now, since we are talking about x being a number of products or a number of units of a product, when we're graphing this, we're only going to be graphing positive numbers because in the context of this problem, it doesn't make sense if we were to say, how much does it cost to make negative 10 units? So that is why I am only graphing the first quadrant on our coordinate plane. Okay, so I went ahead and I plugged in some numbers into our function so that we can kind of get an idea of what the graph is going to look like. So if we plug in 1, our output is 904. I'm just going to go ahead and fill in some more values into our table. All right, so I have filled out my table as well as filling out the grid lines and the tick marks on our coordinate plane. So let's go ahead and plot some of these points. So at 10 units, sorry, I just realized that this should be C bar, our average cost function, as well as that one. So at 10 units, our average cost per unit is going to be about $103, which is like right there. At 20, it will be 68, which is about right there. 30, it'll be 63, so it's slightly lower. 40, it'll bump back up a little bit at 65.5. And 50, it would be 71. And at 60, it would be 78, so like right there. And so if I graphed my function now, it's going to look something like that, and then it's going to curve back up after 60 units. Okay, now the second part of our question says determine the minimum average cost, and for the scope of this class, we will not be talking about how to do that algebraically or via other methods. You will explore that if you take either calculus or business calculus in the future, ways of doing that without having to refer to a graphing utility. But for the purposes of this class, for this specific question, I'm going to have you either look at Desmos or your graphing calculator. And if you throw this onto Desmos, you will find that the minimum occurs right here at 30. You'll see it highlighted on Desmos. So we could just say that from our graph, the minimum average cost is $63 when we sell 30 units of product. Okay. Now, we're going to talk about another kind of function, and these are called piecewise functions, and we've touched on them in an earlier unit when we started talking about functions in general, and you've also should have seen this example when we first talked about it, but let's remind ourselves. The absolute value function is equal to, and remember piecewise functions are usually defined by using this large curly bracket, and we are breaking it into chunks. So the absolute value function has an output of x if our input x is greater than or equal to 0, and it's negative x if x is less than 0. Now, if we wanted to graph that, what would that look like? So here's our y-axis, here's our x-axis. Let me make an xy table really quickly. So if I plugged in -4, let's say, that is a number that's less than 0. So we'd come over here to our two scenarios. We'd have the first scenario or the second scenario. And since our input is less than 0, we would plug it into our second scenario. And -4 times -1 is +4. So the pattern continues like this. Make another table since I ran out of room. Oops. So essentially, what's going to happen is it's going to make, this V shape. And it'll be mirrored around the y-axis. All right, so that's, I guess, all I wanted to say about the absolute value function, but it's a nice basic example of what a piecewise function looks like. And remember, a piecewise function is just a function that is defined on different intervals. And in this case, the intervals happen to be these things here. So let's move on to talking about example 5. It says the monthly charge for water in a small town is given by the function f of x equals that, where x is water usage in hundreds of gallons and f of x is in dollars. Find the monthly charge for each of the following usages. Okay, so we want to plug in, or we want to find out the charge if the water usage is 15 gallons. So we have these two intervals here. We have if x is between 0 and 20, or if x is greater than 20. So again, we have kind of like these sub-functions 1 and 2. So are we going to be plugging 15 into the first one or into the second one? Pause the video and ask yourself that really quickly. All right, so hopefully you've had some time to think about that. We're going to plug 15 into the first one. Now, something that you're going to want to pay attention to is this is kind of, one of those trap holes that they give you in these word problems. Pay close attention to the fact that X is water usage in hundreds of gallons. So really what this should say is our intervals should be when X is between 0 and, if that's in hundreds, then 20 would really be 2,000 gallons. And then this one should be X is greater than 2,000 gallons. So that there is kind of placed there to be a little bit tricky, so be careful when you are thinking about that. And so because X is being measured in hundreds of gallons, then 15 gallons would really be an X value of 0.15. Here, 30 gallons would be an X value of 0.3, and then 3,000 gallons would be an X value of 30. So please be careful about that. All right, so for A, we would plug in 0.15. However, you want to notice that our first expression here is just 58. It's what we call a constant function, which just means that no matter what your input is, your output is going to be 58. So what that's saying in the context of this problem is that if the town or whatever uses anything below 2,000 gallons, and then it's just going to be a flat rate of $58. So 15 gallons would result in a charge of $58. And then same thing for B, again, because it's less than 2,000 gallons, it falls in that first scenario. So we would also say 30 gallons. I'm just going to put quotations of $58 to indicate that I was copying the same thing from above. Now, we're going to land in a different case when we are using 3,000 gallons. That means that we would plug in x equals 30 into this second expression here, because again, that's the scenario that we're dealing with since our x value is greater than 20, which is another way of saying the amount of gallons that we're using is greater than 2,000 gallons. But remember, our x value is 30 since it's being measured in hundreds of gallons. So I would do 58 plus 0.4 times 30 minus 20. So if I simplify that, that is going to be 58 plus 4, which is 62. So in that scenario, we would say for 3,000 gallons, the charge would be $62. Okay, now we want to graph this. All right, so we wanted to graph our piecewise function. So I've went ahead and gone to the next page and just filled out my grid lines and labeled my axes. In the context of this problem, we also are not going to be dealing with negative input values. And so I've only graphed the first quadrant here. Now, we know that when the townspeople use less than or equal to 2,000 gallons of water, then the cost is $58. So what that's going to look like is it's a constant function, so it's just everything between 0 and 20 on our x-axis is going to result in a cost of $58. So, and then I'm just going to put like a dot right there. So again, it's a flat fee, and so it's just going to look like that. And then basically we are being charged an additional amount for every time we are using gallons more than 2,000. And so what that is going to look like is the second equation, let's remind ourselves, was 58 plus 0.4 times x minus 20 if x was greater than 20. So if I plugged in 20 there, then what would happen is x minus 20 would result in 0, and then that term would disappear, and it would just be 58. So, and again, that wouldn't make sense because we're not plugging in 20, we're plugging in values greater than 20. So let's see if I use 21. So then we would get 58 plus 0.4 times 21 minus 20. And so that's 58 plus 0.4 times 1. So if we used an x value of 21, then the cost would be $58.40. So what we're going to see is that it's going to increase linearly, and our slope is 0.4. So every time our x value goes up by 1, then the cost is going up by 40 cents. And remember, we found our value for when x is equal to be 30, that our output value was 62. So I can kind of plot that there and then just connect those, and our function would look like that, and it would just increase as x goes and becomes a larger value. So that is what our graph is going to look like. Hopefully that makes a little bit more sense as far as piecewise functions go.